Hello everyone, I'm Zahra Fatima. I have done my master's MSc in chemistry from University of Mysore and my bachelor degree from Shadavilas College. And when it comes about my experience, I have 1 year of experience that is working in Citizen Group of Institution that is in Nanjangud. Coming back to this video, that is we are going to start. I'll be trying to explain you regarding chemical cells. Well, let us start with the first one is electrical current. Electrical current is the flow of electrical charges through the medium. For the conduction of an electricity, first and foremost required is an electron. The flow of electrons in any metallic wire or any compound, that is the rate of flow of charges per unit time, is defined to be as an electric current. Usually, the conduction of electrons will be occur only in case of conductors. Then the best conductors are always be metals, because metals contain of free electrons that is mainly responsible for the conduction of electricity. And also, usually, electric current is a flow of electrical charges through a medium in change in the typical carrying or moving electrons in a conductor such as wire. Next comes a cell. A cell is a device which converts chemical energy, and also the cell is the one which is a storing device. For example, any chemicals will be stored in a cells we call to be as a cell. Usually we called another name for the cell as a energy storing devices. Next, coming back to cells, we are broadly classified into two cells. One is galvanic cell and electrolytic cell. In case of galvanic cell, here the chemical energy is being input and the output is an electrical energy. In case of electrolytic cell, we are going to take electrical energy as an input, will getting converted into chemical energy. And the second point is one, a redox reaction is being taken place and it's a spontaneous reaction. But in case of an electrolytic cell, an input of an energy is required for the redox reaction to be proceed in the cell. Hence, we have to supply it energy. It's a non-spontaneous reduction. Spontaneous in the sense which is taken by its own. Non-spontaneous, we have to supply it energy. Then the reaction is going to produce such is called to be as an electrolytic cells. In this electrochemical cells, the major difference is anode is negative charge and cathode is positive charge. In case of electrolytic cell, positive is anode and negative is cathode. The electrons are oriented in the species that undergoes oxidation. Electrons are original from an external source such as a battery. Let us going back to the batteries we have. It's a redox reaction where oxidation and reduction occurs simultaneously, are said to be as a redox reaction. For example, oxidation in the sense addition of oxygen and also removal of oxygen, or else in case of reduction it is the removal of oxygen and addition of oxygen. Hence redox reaction is it's an input we are taking it and going to release an electrical energy. In this, we have two types of batteries, that is primary battery and secondary battery. Primary battery is the lithium battery and mercury battery. Secondary battery are lead storage battery and fuel batteries. Coming back to primary batteries are that which converts a chemical energy dischargeable only at once. We can use it only at once and we cannot use it further back. And electrochemical reactions occurs in the cell is not reversible and unchargeable. Examples are alkaline batteries, zinc chloride, silver oxide, mercury battery. Construction is very simple. There will be a metal of anode and that is will be responsible as stable for the moisture air and slowly tendency to be prevented as a passive in the cell, and the aqueous will be highly conductivity which is an electrolyte, and the relatively nobilized cathode will be placed and a cathodic depolarizer is being used. Lagrange's cell. It's a primary battery and non-chargeable. Here the output is result is only 1.5 volt and used in the transistor and clock cells. Okay, when it comes about to be construction, it is originally Lagrange's cell is a depolarizing and it's crushed of magnesium oxide which is packed in a pot and a carbon rod is inserted into it that act as a cathode. An anode is an oxidizing reaction where zinc is immersed along with a pot in a solution of an aluminum chloride and zinc chloride. The liquid of aluminum chloride and zinc chloride solution is jelly, which is a starch acting on an electrolyte, which is a porous of the pot which makes in contact with an cathode. Okay, fine. The zinc containing also serve to be as an anode, and the electrolytes forming a jelly that the central carbon rod or the bars cap of an electrolyte will be acting as an anode. Okay, the reaction is going to be formed as it is shown that in case of anode oxidation occurs, the zinc will give out two electrons and goes to Zn2 plus state. And in case of cathode, MnO2, it's oxidizing and it takes one electron and forms MnOHO and ammonia gas is going. This ammonia gas elevation is a to maintain, it's a gas which is making, it's an exothermic reaction, hence to this gas should not get come out from the reaction. We have been taking it react with again zinc and forms a complex forming a Zn HNO3 that an aqueous. And certain conditions are the reaction is made in cathode is more alkaline as produced. If you wanted to make it cathode to be as a more alkaline, the pH of this solution is nearly the cathode, thus increases with the time and the intensity of discharging. Hence, polarization of cathode at the rate of discharging with time. The overall decrease in EMF of the cell depends on the time of discharging, consequently by both accumulation of Zn2 plus ion and an anodic as OH minus ion in the cathode. Thus, the increase in Zn2 plus ion concentration can also lead to the precipitation, which increases the internal resistance. That is the reason this we are going to get complex. During this working of zinc as Zn2 plus ion and migration from from an electrode, the use of this manganese will be ammonia will going to be neutralized and forms a complexes. Next is a magnesium, that is mercury cell. Here the exactly same as how Lagrange cell, just in case of zinc we are replacing by mercury cell. It's a primary battery or primary cell which is a non chargeable, and an output voltage is 1.35 volt and it is used in your clock cells. And hearing, the one who cannot be able to hear it will be a one cell will be placed inside that will have a this type of batteries. Okay, in the cell HgO is used to be as a depolarizer. Hg, mercury oxide, is used to be as a depolarizer, and this mercury oxide is mixed about to be as a half weight of the graphite and mixed with a compressed into a cake in a shallow sealed can, which act as a part of the cell container as a ter- terminal conductor. Okay, during this initially discharging of the cell, the cathode in graphite, but later oxide of red is being increases the current carrying by mercury. Next, the anode of the cell is zinc amalgam with 10% of its weight of mercury. The electrolyte is 35.4 percentage of an aqueous potassium hydroxide KOH, which is being saturated with potassium zincate, and zincate has been dissolved with 5% of zinc oxide in an alkali solution. When it comes about cell reaction, the anode reaction is being dissolved by zinc following by the precipitation of zinc hydroxide. Zn will going to form, and in case of anodic reaction, the zinc mercury will interact with OH minus ion. It gives up two electron and forms zinc oxide. That is, zinc is addition of an oxygen is being taken place, it is going to form zinc oxide and H2O, and the two electrons is going to be released. Cathodic reaction, this HgO, mercury oxide, the two electrons released from an anode will going to take up and the water will be placed. It is going to produce Hgi plus 2HOH minus ion. The overall reaction here, the two electrons has been cancelled by one more and OH minus ion are cancelled by one another. Here this OH minus ion, this OH minus ion is cancelled by this one, and these two electrons are cancelled by this, and water has been cancelled by this and forms Zn and HgO going to form zinc oxide plus mercury. Next we'll be having as lead storage battery. Here, according to lead storage battery, it's a secondary battery. The cell in which this chemical reaction can be made to produce either directly or suitably with a current, electric current, is called to be as a secondary cell. The term accumulator is that these are the cells batteries which can be again chargeable or called to be as a secondary battery. And that first and foremost is lead storage battery. It's a strong lead has been used as an anode. A strong lead has been used as an anode, and the lead accumulated will be coated with this, with a lead dioxide, and cathode as a cathode. An anode will be lead, strongly lead, and cathode will be lead dioxide. And 27.4 aqueous sulfuric acid is used as a electrolyte. 30% of sulfuric acid is used in a as an electrolyte in this type of batteries. An insert porous insulator act as a separation between the each pair of electrodes. The regulator plates are being separated, completely assembling and immersed into an acids. When it comes about cell reaction, we have an anode in the sense where oxidation will be taken place with addition of an oxygen to lead. Lead, when from the sulfuric acid, SO4 minus ions will be combined and forms lead sulfate with the true release of an electron. Addition of an oxygen has been taken place. In case of anode, there will be an discharge of ionizing of lead to be divalent state followed to the precipitate of lead sulfate in this anode. What happening is this Pb will be 2 plus ion state will goes to PbSO4. In case of cathodic reaction, combination of overall what it is an equivalent to sulfate ions is consequently H2SO4 is removed from an anode. The cathodic reaction relates to the decomposition of PbSO4 which consumes a water molecule. What happening in case of cathodic reaction is this PbO2 lead oxide. We have cathode in the sense it was lead oxide, the sulfate ions and H plus ion. The overall complete sulfuric acid is going to react and the two electrons which is produced will lead to the formation of a water and lead sulfate. The overall reactions will be of PbO2 Pb plus PbO2 plus sulfuric acid give 2Pb sulfuric acid plus water and electricity. The discharging of lead acidic cell and the above overall reaction will be produced from left hand side to the chargeable accumulator. And nowadays this have a wide application and most of the batteries used in your vehicles are made up of lead storage battery. And the last one is fuel cells, which is an electrochemical cells that converts chemical energy into fuel. Oftenly hydrogen is been oxidizing agent and oxygen is will be undergoing to be reduction, hence a redox reaction is occurring in the fuel cell. A fuel cell is different from the secondary battery that is not chargeable and it is in conventional manner. Fuel cells are producing electricity continuously as long as the fuel of oxygen has been supplied. The design of the fuel cell is been primitively moment for the fuel to be oxidized and reducing oxygen will be coming out. The reaction of this is H2O2 fuel cell is based on the combustion of a hydrogen into water. That is H2O plus oxygen. As you burn it oxygen, it is going to produce water and energy. The electrodes are made up of porous graphite immersed it with a lead, silver or a metal oxide as a catalyst. And an aqueous solution of KOH and NOH electrolyte is being in contact with the graphite rod. Oxygen and hydrogen are continuously passing through the cell. The gas diffusion into an electrode porous and process an electrolytic solution. Hence, in case of anode, H2O gas when react with OH will be produced by water molecule. It is going to produce water and two electrons. In case of cathode, the oxygen has been taken up and water molecule that is completely here the burning of an water will be broken up by hydrogen H2 and oxygen and produces energy. The overall reaction will be the formation of water H2 oxygen going to produce an energy. The EMF of the cell is found to be as a 1 volt. The water produced by vaporization oftenly will be cell operated at 100 degrees Celsius can be condensed or used. In place of KOH and NOH, phosphorus acid can also be used as an electrolyte if the cell is operating at 200 degrees Celsius. As the temperature of the phosphoric acid polarizing and phosphoric acid will be condensed to be highly ionic conductivity than the parental acids. Thank you. This completes the end.